5-32, and they didn't have a good other problem sample, so I kind of made up my own. You guys are dealing with days of the week, so I decided to do it months of the year, so it's really simple, and hopefully I can kind of explain it a little bit as I go along. But in your case, if you ask, I'll just change it. If I asked 5 strangers then about their birthdays, what's the probability that all were born in July? Okay, well, what's the probability that the first one, if you ask any single person, on the street, if they were born in July, it's really 1 out of 12. Okay, now I understand there's longer months and there's shorter months, and there's also probably bigger probabilities depending on weather and a few things like that, but let's keep it a little more simple here in terms of my months, because then that'll apply to your days of the week anyhow. So it would be 1 out of 12, right? That the first one. If you ask the second person, what's the probability that that second person was born in July? It would also be 1 out of 12. Okay, and so on and so forth through all 5 people. And so the answer then, and you want the probability that all of them, then you go back to your rule of multiplication and you just say, well, then that's 1/12 times 1/12 times 1/12 times 1/12 times 1/12, or 1 divided by 12th, 1 divided by 12, to the 5th power. And we could do that. We could just say this is equal to 1 divided by 12 to the 5th power. Should work out. Okay, it's a small number. Okay, that's what I'm getting there when it says it's to the -6. So I'd have to go over 6 decimal points from there. So 0.00004 is something to that effect. So it would be a small chance that all 5 people that you randomly select would be born in July. Okay, then what's the odds that they were all born in different months? Well, here again, if you ask that first person, what month were you born in, it doesn't really matter, right? It's different than himself, or different. It's 12 for 12, okay? Because we're not comparing him to anything. But then the second person we ask, well, we eliminate 1 month, and so he's got one chance in 12 of being in the same month, 11 chance in 12 of being in a different month. And so we just keep going down through all 5 of them. So the third person has a 10 chance in 12 of being in a different month, and the fourth person a 9, and the fifth person an 8 chance. And then we would multiply all of those together. Okay, and I'm going to skip that because I'd have to manually put that in there, but it'd just be equal to 1 times 11 twelfths times 10 twelfths times 9 twelfths times 8 twelfths. Okay, there we go. Now, the last one is what's the probability that, and I put none born in the month of November. Okay, that none of them were born in the month of November. Well, if I'm ruling out 1 month, okay, then I've got, and for each person that I ask, right, it's just kind of the opposite of this one. I've got an 11 out of 12 chance that they weren't born in that month, right? So if I ask that first person and I say, were you born in November? There's 11 out of 12 chances that they would say no, okay? And that's going to be the same for each person. So here I've got 11 divided by 12 to the 5th power, and this one I can calculate, equals parentheses 11 divided by 12 to the 5th power. About a 65% chance that none of them were born in November. That should help you guys with your problem 32.